Hey everybody, in this video we are continuing our journey through some algebraic techniques for finding limits. We already covered technique 1, which is to factor and reduce. Technique number 2, we're going to focus on long and or synthetic division. I will do a very mini review of both methods, how to do them, why we can do them, tricks for using them beyond just dividing, how to kind of get a double whammy with something like this. So let's go. Here I have an example. This is example 2. We already had example 1, like I said, and before that a review of some limit rules that you more or less use while doing something like this. Okay, so here I have a quotient of two polynomials. The limit is asking us to approach 4. We can do direct substitution really in the top and the bottom and then find the quotient. But there's a disclaimer when it comes to a quotient. The denominator can't be 0. If we get 0 in just the denominator, all right? If you get some other number on top and 0 on bottom, that basically implies, okay, oh, not showing. That's a number over 0, a vertical asymptote. And you'll probably have to, figure out, are my branches pointing in the same direction? Are they pointing the opposite direction? If they're pointing in opposite, you'll say straight up DNA. If they're both pointing in the same direction, you might put something like infinity, yada, yada, yada. That might require you to do a little bit of graph sketching, maybe not, depends on the situation. But if you get 0 over 0, it looks like a division sign. It's called indeterminate form. We talked about this in a previous video in this series. And that basically is telling us, division symbol, right, that we're going to be able to cross something out from top and bottom. Okay? Very, very important, right? So if we were to try direct substitution first on this, plug in 4. Now it's kind of annoying to plug in 4, I'm not going to lie. You have to do 2 times 4 to the third, right? Minus 3 times 4 squared. Oops, sorry. Minus 23 times 4 plus 12. 4 to the third. I'm just going to squeeze as much work as I can above here because this isn't going to matter so much in a minute. So it's 2 times 64. That's 128, right? Minus 3 times 16. Okay, that's 16. And 3 times 16 is 48. 23 times 4, 23, 46, 46, 92. Plus 12. Let's see. Negative 92 plus 12. They both got 2's going on in there. That's going to equal negative 80. 128 minus 48. Well, 120 minus 40. Same answer, 80. 80 minus 80, the top is definitely 0. Now the top equals 0, that's okay, but if the bottom also equals 0, which obviously 4 minus 4 is 0, we got our indeterminate form, okay? No one is expecting you to always do that, but you should kind of try to do it at least in your head, okay? You should try to do it at the very least inside your head so that you know you're not wasting your time by doing all these other algebraic techniques, okay? So, why can't I factor and reduce, you ask? Well, you can. However, how do I factor this numerator? I can't use GCF. I cannot use difference of two squares. I cannot use the sum and difference of two cubes. I cannot use the AC method. I cannot use grouping. It doesn't work, right? Cannot use grouping. You would have to use the rational root theorem. So you would have to get all the factors of the first and last. You make your ratios, rational roots. Roots are x-intercepts. And you are going to test them with synthetic division. And no, nobody's got time for that. So we already know a root because of our direct substitution. One of our roots, or x-intercepts, has to be 4. Because when I plugged in 4, I got 0 as my answer. Now remember, if you watched the last video, what is a better trick? Remember that mess I just made up here, plugging in 4? What was the other trick that I could do for plugging in 4? Well, I could do synthetic division with 4. I'm going to put my coefficients. Now again, when you're dividing with synthetic division with 4, that really means you're dividing by x minus 4, okay? I'm going to put my coefficients. 2, negative 3, negative 23 and 12. Leaving a little space, drop down the first number. Bottom number 2 times box number 4 is 8. Add straight down 5. Bottom times box, 5 times 4 is 20. Add straight down negative 3. Bottom negative 3 times box 4 is negative 12. Add straight down 0. The remainder, that's the remainder, is your output, and that is what I got. Isn't this math a little cuter than the math I did before? Right? Now, why is this a double whammy? Not only did I find out it makes my numerator equal 0, right? But I also basically already factored. What do you mean you already factored? I'll tell you what I mean. We just said that the 4 in the box means 1. We're dividing by x minus 4, so that's 1 factor. My quotient, the 2, 5, and negative 3, those are my coefficients of my quotient. That's the other factor. That's how dividing works. Just think about any other set of numbers, right? Without polynomials. That makes this 2x squared plus 5x minus 3. If you don't know synthetic division, you have to go learn that in a separate video. This is just assuming you know it and need it a little chat and refresh, right? So that is essentially my numerator. My denominator is x minus 4, and I still am finding the limit as x approaches 4, right? Now, this guy on bottom, as I've described it before, right, is the problem. I am allowed to get 0 on top. I just cannot get 0 in the denominator, right? I'm not allowed to get 0 in my denominator. Getting 0 in the denominator is the problem, right? I need it to cross out. I leave it nicely little structured so that I can see where it is, so that I don't lose track of what I'm trying to cross out, and that I'll eventually be able to carefully cross it out, and then I'm basically patching up a hole in a graph, and I will do direct substitution from there. So I'm going to go ahead now and cross out. So gone and gone. That means I'm only finding the limit now, the limit as x approaches 4 of 2x squared plus 5x minus 3. That's what I'm going to do. Now, again, we have two options, right? What are my two options, you may ask? Option 1 is, well, direct sub. 2 times 4 squared plus 5 times 4 minus 3. 4 squared is 16 times 2 is 32 plus 5 times 4, 20 minus 3. 32 plus 20 is 52 minus 3. Final answer, 49. Winner, winner, chicken dinner. But come on, guys, let's be so much smarter. How can we be so much smarter, you ask? We can be so much smarter because we know I'm going to have to do direct sub into the 2x squared 5x minus 3, right? The whole mess. Pretend that this, let's erase this whole problem for a moment. So I already have that whole line written, right? Again, the remainder is dead to us now. We're done with the remainder, okay? So, and this I don't have to think about. Let's pretend that's not there. I already have these numbers on my paper from the division, right? Just divide again. Just divide. 2 times 4, 8, add 13. 4 times 13 is 52. Like, how many cards are in a deck? Negative 3 and 52, 49. And there you have it. We get the answer that way as well, right? So, think smarter, not harder. Go through this video again if you have to. Oh, I promised I would show you long division. So we could only do synthetic when you're dividing by something like x minus 4, x plus 2, x minus x plus 2, x minus 2, something along those lines, right? It can't be like 2x plus something. It can't be x squared, anything like that, okay? So long division, you're allowed to do all the time. So let's look at long division. X minus 4 is on the outside. Inside, 2x squared minus 3x squared. Oh, I lied to you. Oops. 2x cubed minus 3x squared minus 23x plus 12. Then we focus on the leading terms like line leader, oops, line leader divided by line leader. So who are, and again, leading terms, that should be ringing a bell. It's kind of what matters most of the time. But leading term. So it's 2x cubed divided by x. And what does that equal? That equals 2x squared. You write it above the other squared term, so you have columns with the same power. Then basically you're always going to do work here, work up here, go over here, right down here, go under here, back around and around and around and around. If you go around and around, you're probably doing it correctly. So I'm going to take 2x squared now, multiply it to this, and write it under here, okay? It's going to go in there. So the 2x squared times x is 2x cubed. 2x squared times minus 4 is minus 8x squared. Then I always say, parentheses, minus sign, underline, cancel. Now, don't distribute the negative on paper, just do it in your brain. Negative 3x squared minus negative 8x squared means plus 8x squared. That gives me 5x squared. Bring down the next term, minus 23x. If this is a binomial out here, each step of the way you should have binomials. If you had a trinomial out here, each step of the way you should have trinomials inside, okay? Now, what do? I'm glad you asked. We're going to also do leading term by leading term, just like before, but now 5x squared divided by x, and what does that equal? Positive 5x. So up here, plus 5x. Multiply it by this guy on the side. 5x times x is 5x squared. 5x times negative 4 is minus 20x. And again, the phrase that pays is parentheses, minus sign, underline, cancel. If that first thing doesn't cancel, you're not doing it correctly. Even if the next thing gives you basically 0, don't cancel. Write 0x or 0x squared and carry on and do the steps as per usual, okay? Negative 23 minus negative 20 is plus 20, so that's negative 3x. Drop the next term, plus 12, and then we repeat. Negative 3x leading term divided by x leading term is negative 3. Multiply that guy by that right there. And do I even have room anymore? Maybe. Negative 3 times x minus 4 is negative 3x plus 12, parentheses, minus sign, underline, zoop, and cancel. And then 12 minus 12 is 0. That's my remainder. It divided evenly. That is long division. I hope you loved it. I hope you were able to hear me too. I don't know how my audio setup is right now. Yeah, so if you loved it, well, and appreciate, look, I just gave you so much gold, okay? That was gold in like 12 minutes, 13 minutes. So if you loved it and you could appreciate, then go ahead and, where is this? Give a video a thumbs up, right? Keep the girls happy. If you hated it, go ahead, thumbs down, whatever. But I hope you're happy. And questions, comments, concerns, requests, feedback, put that in the comment section down below. Check the description box or the playlist at the end thumbnail on the screen for more videos on this particular topic. And I hope you feel smarter today. That's it for now. Adios.